Okay, so let's continue on section 4.3, and we're gonna take a look at right triangle trigonometry. So we're gonna interpret all these different trigonometric functions, identities in a right triangle. Okay, so here, let's say you have a right triangle, 3 sides. This is called a hypotenuse side. So with respect to angle theta, A is the opposite side, B is the adjacent side, and then C, that's the hypotenuse side. And we could define sine, cosine, tangent, cotangent, secant, cosecant from this right triangle trigonometry. So sine theta equal to opposite side over hypotenuse is A over C. Cosine theta equal adjacent side by the hypotenuse side, so B over C. Tangent theta is equal to opposite over adjacent, so A over B. And then if you know cosine, then cosecant will be the reciprocal of sine, so we can C over A. And then secant theta is going to be the reciprocal of cosine, C over B. And cotangent theta is a reciprocal of tangent, so it becomes B over A. So we define all 6 trigonometric identity here in this right triangle. Now in this particular section, we will evaluate trigonometry functions of acute angles. Use a calculator to evaluate trigonometry functions, use fundamental trigonometric identities, and then we're going to learn how to use the trigonometry function to model and solve real-life problems. Okay, so let's look at the 6 trigonometric functions. Again, and we are coming from the right triangle here. Right triangle is the foundation for the trigonometric functions. So this is hypotenuse side, opposite side, and adjacent side. And typically draw a right triangle and then put in the angle theta. Theta goes here. Now opposite side you can use A, adjacent side you can use B, and hypotenuse side you can C. And also the Pythagorean theorem applies here. That means A squared plus B squared equals C squared, according to Pythagorean theorem. So if you note any two of the sides, you can find the missing one from the above equation. And using the length of these 3 sides, you can form the 6 ratios. So sine equal to sine theta equal to opposite over hypotenuse. And cosecant theta with the reciprocal, so it's hypotenuse over opposite. That's first group. Second group, cosine theta equal adjacent over hypotenuse. And then secant theta, and it's reciprocal, so it's hypotenuse over adjacent. Last group is tangent cotangent. Tangent theta equal opposite over adjacent, so cotangent theta equal to adjacent, it's reciprocal of tangent, adjacent side over opposite side. And now let's look at right triangle definition of the trigonometry functions. And we already list all those different definitions here. Okay, Sine theta equal opposite over hypotenuse, cosine theta adjacent over hypotenuse, tangent theta, cosecant theta, secant theta, and cotangent theta. Then OPP represent the length, opposite side of angle theta. ADJ represented adjacent side of angle theta. And then hypotenuse, the length of hypotenuse side. Okay. And now, again, this is still, theta is located in the first quadrant. And if you're in the first quadrant, everything is positive, right? So you can do this. I'll show you the mnemonics. So in the first quadrant, quadrant number 1, all 6 of them are positive. All 6 trig identities are positive. So you can remember this mnemonics. All students take calculus. First quadrant, every one of them are positive. Second quadrant, sine and then cosecant are positive. If sine positive, then cosecant positive. And in the third quadrant, T represent tangent positive. If tangent positive, then cotangent is also positive. And then last quadrant, cosine is positive. The reciprocal of cosine is a secant, and secant is also positive. Again, those mnemonics are very useful when we determine the sign of any trigonometric function. Then you can always draw the Cartesian system and put in all this important information. Now let's take a look at this. This triangle in figure 4.20. We have a right triangle here. This indicates as right triangle. In this right triangle, angle theta right here, adjacent side is 3, opposite side is 4. So you can use Pythagorean theorem, right? To find using Pythagorean theorem. So this is hypotenuse side C. So C squared equal to A squared plus B squared. And then hypotenuse equal to radical 4 squared plus 3 squared is radical 25. It turned out to be 5. So C equal to 5. Okay. Now once you know that, opposite side will be 4 over hypotenuse side 5. Cosine theta. Let's draw it really quickly. Theta right here. Opposite side is 4. Adjacent side 3. Hypotenuse side is 5. So sine theta equal opposite over hypotenuse 4 over 5. Cosine theta is adjacent over hypotenuse 3 over 5. Tangent theta is opposite over adjacent 4 over 3. Cotangent theta is hypotenuse. Cotangent theta is adjacent over opposite. Cosecant theta is hypotenuse over opposite. So 5 over 4. And secant theta is hypotenuse over adjacent. This is adjacent. And then cotangent theta adjacent over hypotenuse 3 over 4. Okay, so that's how we publish. Once you know A, B, and C, then meaning you know hypotenuse, adjacent side, and opposite side, then you can find all 6 trig identities here. Now let's take a look at some special angles. And we have 3 types of special angle. First one is 30 degree. So for 30 degree angle, let's say this is 30 degree angle, right triangle. For 30 degrees angle, and we know that if this is 1 unit right here, then the opposite side of that will be half unit, and the adjacent side will be radical 3/2. Again, you can use geometry to solve this. Extend it, right, and then connect it from a 60-degree angle here. And this is 1 unit, half of it will be half unit. Using Pythagorean theorem to get adjacent side radical 3/2. So sine 30 degrees equal to opposite over hypotenuse is half over 1. Sine 30 degrees, it's half over 1, that becomes half. And then cosine 30 degrees, and it's going to be radical 3/2, adjacent side over hypotenuse, so radical 3/2. And tangent theta, tangent 30 degrees, and it's going to be opposite over adjacent. And if you simplify this, cancel the 2, it's 1 over radical 3. Rationalize that, you get radical 3/3. So radical 3/3. And since we know this, if this is 30 degrees, then 60-degree angle is right here. So we know that we can also find out what is sine 60 degrees. Sine 60 degrees is opposite is radical 3/2 over 1. So it's radical 3/2. Cosine 60 degrees is adjacent side of 60-degree angle is half over 1. It's half. And tangent 60 degrees is opposite radical 3/2 divided by half. That turned out to be radical 3. Okay. And that will take care of those 30 degrees and then 60 degrees angle. And for 45 degrees, we insert a blank page. And let's look at a 45 degrees angle. Okay. All right, so let's say it's a 45-degree angle. If this is 45 degree, this is 90 degree, then the remaining angle will be 45 degree. So if you look at this is 1 unit, because 45 equilateral angle, if this is 1 unit, that's 1 unit. And the hypotenuse side must be radical 2, 1 square plus 1 square. So c square equal 1 square plus 1 square, c equal 2, c square equal to 2, c equal radical 2. Now sine 45 degrees is equal to, so let's say this is angle theta right here, is 1 over radical 2. If you rationalize the denominator, is 1 over radical 2, multiply radical 2 on both top and bottom. So it's radical 2 over 2. Cosine 45 degrees, it's adjacent side 1 over hypotenuse radical 2. And rationalize that is also radical 2 over 2. And tangent 45 degrees equal to opposite over adjacent 1 over 1, that becomes 1. And that's how you find a special angle 45 degrees. And now, as you noticed earlier from this earlier demonstration, sine 30 actually equal to cosine 60, right? They are equal to each other. Cosine 30 equal to sine 60 degrees. If you look at the value here, that actually tells us something about this sine cosine. Sine 30 equals to cosine 60. And if you look at angle 30 and 60 degrees, if you sum up those two angles, it's 90 degrees. So if two angles sum up equal 90 degrees, we call this complementary angle. So we have cofunction of the complementary angles are equal to each other. That means sine 90 degrees minus theta equal to cosine theta, because these two are complementary angles. 90 degrees minus theta plus theta give us 90 degrees. And cosine 90 degrees minus theta equal to sine theta. Tangent 90 degrees minus theta is equal to cotangent theta. So by applying the complementary angle concept, sine becomes cosine, cosine becomes sine, tangent becomes cotangent, cotangent becomes tangent, secant becomes cosecant, and then cosecant becomes secant, because they are complementary angles. And let's look at some more trigonometric identities, and they are pretty useful in terms of solving some trigonometric problems. First one, we call this reciprocal identities. And we know that sine, cosecant are reciprocal. So sine theta equal to 1 over cosecant theta. Cosine theta and cosecant and secant theta, they are reciprocal. So cosine theta equal to 1 over secant theta. Tangent theta and cotangent theta, they are reciprocal. So tangent theta equal to 1 over cotangent theta. And then you just swap those two identities, you get the following three. Okay. Cosecant equal to 1 over sine, secant equal to 1 over cosine, cotangent equal to 1 over tangent. We also have a quotient identities, meaning tangent theta you can express as sine theta over cosine theta, and cotangent theta is equal to cosine theta over sine theta. You can take a look at cosine, cotangent, cosine. And Pythagorean identities, and we can easily prove the Pythagorean identities. Let's say you have a right triangle here, and this is A, that's B, that's C. Angle theta is right here. So sine theta equal to opposite B over C. Cosine theta equal to A over adjacent side A over C. So sine theta squared plus cosine theta squared, that's equal to B over C squared, adding A over C squared, and this is equal to B squared over C squared plus A squared over C squared. And put it together, and then A squared plus B squared over C squared. And then we know that C squared, according to Pythagorean theorem, C squared equal to A squared plus B squared. So that becomes 1. Okay. That's why sine theta squared plus cosine theta squared equal to 1. So we prove the first Pythagorean identities. If you look at the other two, we can easily find that by using the first identities. Let me include another slide to help you understand this. So again, we already have sine theta squared plus cosine theta squared equal to 1. Now look at this. If you're dividing everything by cosine theta squared, and rearrange it, this first one could be becomes sine theta over cosine theta. Put out the square side outside. So cosine theta squared over cosine theta squared becomes 1. And the other one you can rearrange it as 1 over cosine theta, parentheses squared. Sine theta over cosine theta, that's tangent theta. Square that, plus 1 equal to 1 over cosine is secant theta. And square that. So now you end up with a tangent theta square plus 1 equal to secant theta square. I'll prove one of them. So that's the second Pythagorean identities. The third one is still start with sine theta square plus cosine theta square equal to 1. Now we're going to divide everything by sine theta square. Then get the last Pythagorean identities. Sine theta square over sine theta is 1 plus rearrange it is cosine theta over sine theta parentheses square, and the last one is 1 over sine theta parentheses square. This is cosine theta over sine theta is cotangent theta square. 1 over sine theta is cosecant theta parentheses square. So you have the third one, 1 plus cotangent theta square equal to cosecant theta square. Okay. And that's how you prove these three Pythagorean identities. Alright, so know that sine theta square represents this. So this is equivalent sine theta square equals sine theta parentheses square. Cosine theta square equal to cosine theta parentheses square. Note that sine theta square is not the same thing as sine theta square, right? This is angle theta square, so they are not equal to each other. Also, cosine theta square is not equal to cosine theta square. So this is very important. Notice the difference. And that theta being a acute angle. Acute angle indicates it is in the first quadrant. Angle located in the first quadrant. That means all 6 identities are positive, all 6 of them. So cosine positive, tangent positive for sure. Okay. And in order to find the cosine, we can use a Pythagorean identities, because sine theta square plus cosine theta square, that's equal to 1. So now replace sine theta with 0.6. So 0.6 goes here, so it's 0.6 square plus cosine theta square equal to 1. Now it's 0.36 plus cosine theta square equal to 1. And subtract 0.36 from both sides equation. And cosine theta square equal to 0.64. Now typically when you're taking a radical on both sides equation, you put plus minus. But since we know the angle is located in the first quadrant, so everything positive, so cosine theta must be positive. So we only keep the positive answer, radical 0.64. That turned out to be 0.8 positive. And if you know cosine theta, then you know sine, cosine using the quotient identities, tangent theta equals sine theta over cosine theta. So that's going to be 0.6 over 0.8. And then if you simplify, you become 3/4, 3/4. Yep, that's it. Yeah, so this is basically how you look at it. Tangent theta equals the tangent angle is equal to opposite over adjacent 0.6 over 0.8. So that's also equal to 3/4 once you simplify that. And you can divide both top and bottom by 0.2 to get 3/4. So basically we apply some trigonometric identities to find these missing elements. Now next thing, let's take a look at some applications with the right triangles. We call this process solving right triangles. Sometimes it's missing sides, sometimes it's missing angles. A couple important terms you should be recognize is angle of elevations. So let's say this is horizontal or horizon. Let's say horizon. observers right here, objects right here. So we get angle of elevation. The reason why it's called angle elevation because it's moving counterclockwise. From the horizon to the objects, we rotate angle counterclockwise. So that's called angle of elevation. If a horizon is right here and then objects underneath it, and this is called angle of depression. Angle of depression is formed by rotating angle clockwise. And these two are pretty important in terms of navigations, or like measure the height of building, measure the height of object in our daily life. Let's take a look at this. Let's say a surveyor is standing 115 feet from the base of the Washington Monument. So this is the person right here. This is Washington Monument. The measurement between the center of the monument, also the people, is 115 feet. If you look at it, you can form a right triangle here. Monument is perpendicular to the horizon, right, to the ground. So you can form a right triangle here. And also we know that the surveyor measured the angle of elevation. Okay. So going from this to object, it's right here. So we're doing the horizon to that. So the angle is 78.3 degrees. And that's the angle of elevation. And you want to find out the height of the Washington Monument. So this is the height, right? And we're using y to represent the height. So let's form the relationship using trigonometric function to express y. So if you look at the height of the monument is opposite side of the angle theta, yeah, angle of elevation, angle theta. So look at it, relating the opposite side and adjacent side, we got to use tangent theta. Tangent theta equal to opposite side over adjacent. And relate the given information, also the missing information using the trigonometric function. So tangent theta is tangent 78.3 degree. And the opposite side is turned out to be y. Adjacent side is 115 feet. Then you can utilize this equation to solve for the missing element here, y over 115. Yes. So in order to solve for y, you just multiply both side equation by 115. So cancel that 115, y value equal to 115 times tangent of 78.3 degrees. And you put into the calculator, and you'll be able to get a result. That's how you solve it. And the answer is listed in the back. All right, as mentioned, so y equal to 115 feet times tangent of 78.3 degrees. And plug into the calculator. And you want to make sure that your calculator is expressing a degree measurement. And let me check my calculator. And the answer turned out to be 553.31 feet, approximately. Approximately equal 555.31 feet. And that's the height of the monument after applying the formula. So by now you recognize that theta equal 30 degrees, sine theta equal half. If theta equal 45 degrees, then it's radical 2 over 2, that turned out to be 0.7071. So if let's say we have something sine theta equal 0.6, then the angle must be between 30 and 45 degrees. So using the trigonometric values to refer back to the angle itself. So angle theta here must be between greater than 30 degrees, less than 45 degrees, because sine theta is greater than 0.5, less than 0.7071. Sine theta equal to 0.6. 0.6 is between 0.5 and 0.7071. And we can derive the following, the location of the angle. And that's pretty much everything.